Welcome to the Deep Dive. Today, we're taking a really fascinating journey, looking into the future of artificial intelligence. We're moving beyond the kind of AI you hear about every day, the generative stuff, and exploring something pretty groundbreaking. It's called Sophimatics.
That's right.
Yeah.
Our source material for this deep dive comes, mainly from Sophimatics, Advancing Cognitive AI Through Intentionality and Hybrid Systems. That's by Gerardo Iovine and Giovanni Oban.
Okay.
And they, along with other key researchers, think Jahan, Rushby, Rowley et al., Stendera, Vernon, and Furlong, Bundy et al., they're making a really strong case for a, fundamentally different way to build intelligent systems.
Right. So our mission today is basically to unpack what Sophimatics actually is. Why is it such a big deal, such a leap? And, how does it aim to create AI that doesn't just do stuff, but actually gets it, understands tasks, thinks about its own goals, collaborates in ways that feel, genuinely human-inspired? So get ready for maybe some aha moments, because this could seriously change how you think about AI's potential.
Absolutely.
Okay, so let's start with where we are now, the current state of things. When we talk about today's, powerful generative AI,
Right.
we're mostly talking about systems working in what they call a behaviorist paradigm.
Like training a pet.
Yeah, exactly. It's like you reward the behavior you want, the AI optimizes for that number, that reward score, but does it really understand why it's doing it? Or just that a reward follows?
Precisely, and that's what Jahan and Rushby point out. These current models, they're incredibly reactive, amazing at spotting patterns, generating text or images.
Sure.
But they really struggle with the deeper stuff, reasoning about their own goals, ethics, the actual meaning behind their actions.
Right, the why.
Yeah, the why. And often their decisions feel like they come out of nowhere, a black box. It's often basically impossible to pin down why an AI made a specific choice. It's just unexplainable inference.
Okay, so that's the gap. And this is where Sophimatics comes in and says, hold on, we need more than just chasing points on a scoreboard.
Exactly. It introduces this quite profound concept, phenomenological intentionality. That's a core piece.
Phenomenological intentionality. Okay, sounds complex. How does it actually do that? How does it give AI intention?
Well, it uses different learning methods, like inverse reinforcement learning. Instead of just learning from rewards, it tries to figure out the goals or intentions that likely led to the actions it observes.
So working backward from the behavior to the goal.
Exactly. And it uses things like logical reward specifications to define those goals clearly, giving them a structure that's actually understandable, not just a raw number.
Okay, that does sound like a big shift. So what's the real breakthrough here for us? For the listener, what does this intentionality unlock?
Well, the key thing, the real insight, is that this lets AI systems infer, articulate, even communicate shared intentions.
Shared intentions between AI and humans, or AI and AI.
Both, potentially. The aha moment, and Jaha and Rushby really hit this hard, is that unlike current AI, these Sophimatic systems could actively ask for more info. If they're unsure, they could propose alternatives. They could even negotiate goals.
Negotiate?
Oh, yeah. It's not just about blindly executing a task anymore. It's about understanding the shared why behind it. And that's absolutely crucial if you want real teamwork, real trust, especially in settings with multiple agents, AIs and humans working together.
So for you listening, this means AI might start becoming capable of, self-reflection, reasoning about its purpose, and actually collaborating in a way that feels more like working with another person.
Pretty much. An AI that doesn't just do, but understands its purpose and, crucially, can explain it logically.
And that explainability piece sounds vital.
Absolutely essential.
Yeah.
Because it uses a logical representation for this intentionality, the system can explain how and why it did something, relating it back to those shared goals. That brings transparency.
Which we desperately need.
Right. And it also enables what they call adaptive reasoning. So the rules aren't totally fixed. They can be updated flexibly if unexpected situations pop up.
So it can handle novelty better.
Exactly. And behave differently based on changes in its WELT, its perceived world, its context. That capability makes Sophimatics really promising for AI that needs to make tricky judgments in the real world. From simple stuff to really high-stakes decisions.
Yeah, I can see that.
Johan and Rushby really frame it as the path for AI to move beyond just acting like humans to actually reasoning more like them.
Okay, so to get this kind of understanding and flexibility, Sophimatics needs to tackle another big issue in AI, right? This sort of split between different ways of building AI.
Yeah, the different camps. Traditionally, you've had AI that leans heavily on symbolic, rule-based systems logic, explicit rules, that kind of thing.
Classic Juf FAI, good old-fashioned AI.
Right. Or, on the other hand, you have the neural connectionist approaches deep learning pattern recognition from a vast amount of data.
Which is dominating now.
Mostly, yes. But the problem is, systems based on just one of these paradigms can be surprisingly rigid, especially when things get messy, ambiguous, complex,
Oh.
like the real world.
The rules don't always apply neatly, and the patterns aren't always clear enough for just one method.
Precisely. So Sophimatics suggests a more integrated path. It says, why not use the strengths of both? It incorporates these hybrid symbolic connectionist systems.
Combining the logic and the learning.
Exactly. And there's good evidence for this. Rowley and colleagues, for instance, they showed this really clearly with MRI image recognition.
Okay, how so?
They found that deep neural networks, the connectionist part, became much more robust, much better at generalizing in uncertain situations when they integrated symbolic reasoning into them. The hybrid approach just worked better.
So for you, the listener, the big takeaway here is that these hybrid systems can handle context much better.
Yes. They can explicitly represent context, connecting the meaning of things, the semantics, with the situation they're in. And that's critical because context changes everything, right? These systems can contextualize what entities mean by linking their current context with background knowledge. This leads to, well, richer, more complex meanings, higher level understanding.
So they don't just see pixels, they understand the scene better.
Kinda, yeah.
Yeah.
The outcome is systems that aren't just more precise than single paradigm ones, but they achieve something closer to human-like, context-aware understanding. It's about getting nearer to how we intuitively grasp complex situations.
This all sounds incredibly advanced, but to get to this level of understanding, Sophimatics goes even deeper, doesn't it? It pulls from philosophy.
It does, yeah. It's inspired by some really fundamental ideas about what cognition, what thinking even is. Specifically theories like enactivism and autopoiesis.
Okay, let's break those down. Enactivism first.
Right, so from an enactivist view, which Dendera explains well, cognition isn't just about your brain passively taking in sensor data, processing it, and spitting out an action. That's the classical AI view, more or less.
Input, process, output.
Kind of. Enactivism says cognition emerges from the dynamic interaction, the relationship between an agent and its environment. It's an ongoing process of adapting and making sense through action.
We make sense of the world by interacting with it.
Exactly. It's relational, it's recursive, meaning it feeds back on itself.
Okay, and autopoiesis. That
Yes.
sounds like self-making.
That's basically it. Self-creation, self-maintenance. Sophimatics uses this idea to model cognitive systems that can actively sustain themselves, continuously reorganize themselves to maintain their identity while adapting to whatever the environment throws at them.
So they're more self-organizing, more alive, in a sense.
Well, maybe not alive in the biological sense, but definitely more self-organizing and meaningfully embedded in their situation. They aren't just reacting, they're maintaining themselves while reacting and adapting.
And to do that, they need a sense of time.
Absolutely. They need to model past, present, and anticipate future states to recognize how things are changing. Stendera really argues we need to get past seeing organisms, or AI, as just input-output machines.
Right.
Cognition is this ongoing dynamic dance that shapes the system's goals over time.
Vernon and Furlong also touch on this, right? Saying classical AI missed this dynamic aspect.
Yeah, they point out that older models, like the physical symbol system hypothesis, really missed how meaning isn't fixed, but emerges dynamically through interacting with the world.
And Sophimatics, with its enactive approach, embraces that.
It does. It allows for that intentionality we talked about, but also a dynamic ontology. Its understanding of the world isn't fixed, it can evolve. And it allows for goals to be negotiated through shared meaning, where the whole frame of reference is constantly adapting. It's much more fluid.
It's really fascinating how different areas of AI research seem to be pointing in a similar direction here.
It really is compelling. You look at symbolic, logic-based AI, and you look at connectionist neural network AI. And both lines of research seem to suggest that to get truly intelligent, meaningful, adaptive systems, you can't stick rigidly to just one approach.
You have to go beyond the single paradigm.
Right. Take the logic side. Researchers like Bundy and his colleagues found that you really need to supplement logic with learning capabilities.
Oh, so?
They show that if you incorporate something like revised Bayesian reasoning, which is about updating beliefs based on evidence, systems can learn logic rules inductively, even from just a few examples.
Ah, like how humans can often generalize from just one or two instances.
Exactly. It mirrors that rapid generalization much better than pure logic often does.
Okay, and on the other side, the connectionist neural network side?
There too, researchers are finding that just having massive networks isn't quite enough for certain kinds of human-like intelligence, incorporating things like emotional appraisal mechanisms.
Like modeling how we might judge a situation emotionally.
Sort of, yeah. Mapping appraisals like, is this good for me? Can I cope? Onto emotional labels. Adding that layer can actually help these connectionist models make predictions that are closer to human judgments.
So the big picture, the takeaway from all this research.
The takeaway seems clear. Neither logic alone nor pattern matching alone is sufficient to get us to truly meaningful, adaptable, intelligent behavior. The cutting edge across different methods points towards integration.
Which is exactly what Sophimatics aims to provide a framework for that integration.
Precisely. What's so powerful about Sophimatics, I think, is how it systematically takes these long-standing needs and insights from different parts of the AI community and weaves them together. Intentionality, hybrid systems, and activism, autopoiesis. It integrates these powerful concepts into a coherent vision.
So let's bring it back to the listener. What does this all mean for you and for where AI might be heading?
Well, by carefully bringing together this phenomenological intentionality, these hybrid systems, the dynamic understanding of the world, these inactive principles, Sophimatics really does promise AI systems that could be far more expressive, adaptable, and capable of genuine understanding than what we typically see today.
It's not just about building faster or slightly smarter machines.
No, it's about potentially building machines that can truly interact with us, understand context, share goals, maybe even reason with us.
That really does open up some profound questions, doesn't it?
It absolutely does. I mean, think about it. If AI can start to infer intentions, negotiate goals, understand its own history, and anticipate futures, how does that fundamentally change how we collaborate with AI in our jobs, in our everyday lives?
Yeah.
Could this kind of integrated approach foster a relationship with AI that's based on deeper trust, more genuine intelligence? It's definitely something to think about. How might we interact with systems that don't just follow commands, but actually seem to understand?